In order for us to actually connect to the internet from our smartphones, our tablets, our laptops, or computers, we need networks in place. Continuing off of some of the network concepts that we talked about in the previous video, let's go more into network concepts. What we're going to be covering in this video are MAC and IP addresses, valid and invalid IP addresses, including IPv4 and IPv6, TCP and IP basics, DNS or domain name system, and why it is important and how it applies to our networking concepts in general, and some common protocols, including HTTP, HTTPS, FTP, and SMTP. Let's go into TCP and IP first. So essentially, these are our networking basic rules that control how our devices communicate on a network or over the internet. TCP stands for Transmission Control Protocol. It focuses on ensuring that data is both sent and received correctly. It breaks data down into chunks called packets. Those packets are then sent over a network, and then they're then received by another device. It also checks for errors and resends any data if needed. Now, Internet Protocol is a little bit different because Internet Protocol focuses on assigning addresses to devices. So TCP covers the actual transmission of data, hence Transmission Control Protocol. IP, or Internet Protocol, on the other hand, focuses more on assigning addresses to devices. So one of the most simple ways you can think about this is TCP is kind of like a mail service. USPS, UPS, FedEx, it gets mail from one location to another location. It sends mail out. It sends data out. IP, or Internet Protocol, is kind of like our address at our house. That's how computers and other types of devices know where to send the data, is based off of our IP address or Internet Protocol address, just the exact same way we do with mail. So overall, Internet Protocol sends data to the correct destination, and it also helps us handle routing between our networks. Moving on, here's a 4-layer model where you can understand this. Application goes to transport, goes to internet, to network access. There is what's known as a 7-layer model, but you don't need to know that. Don't focus on understanding the OSI model or the 7-layer model. Focus on this very simple 4-layer model for now. And then when you go into more advanced certifications, like say the Network Plus or the Security Plus or the CISA Plus or any other newer, more advanced certifications rather, then you're going to start seeing the OSI model. But for our use case here, don't worry too much about the 7-step model. Worry about this 4-layer model to understand how data is sent out. It goes from application to the transport layer to the internet to network access. From here, we have what's known as our domain name system, or DNS. This is a method of translating website names into IP addresses so that we can access them through the internet. So for example, super simple. Let's say you go out to google.com. You're going to do a search. You type in google.com, punch enter on your web browser. It takes you to google.com. But in the background, what's happening is DNS is finding the exact IP address for that website. So in this case, google.com. Your browser then in the background uses DNS to connect you to that IP address. Then what happens on your end, what you're seeing is you pressing enter and then you being right on google.com. Again, DNS is happening in the background, so you don't manually need to have IP addresses. All you need is a website, .com, .co, .net, .org, whatever website you're browsing out to, you type it in your address bar, you press enter, you go right to the website, because in the background, DNS is working very quickly to get that IP address for your device to actually connect. So essentially, domain name system, or DNS, it converts our domain names, or whatever domain name or website that we're visiting, into IP addresses, so we don't have to remember them. Think about it. It's much easier to remember google.com than, say, an IP address like 176.12.51.94. So that's what DNS is there for. It just makes connecting to websites online very simple. Here's the DNS process flow. Don't worry too much about understanding this in depth. Just understand this is what it looks like. The computer is connecting to a DNS server, and DNS query is being ran, and then that information is being routed from some sort of DNS server back to the DNS server here to your local device, computer, smartphone, laptop, tablet, whatever you're using. So that's what happens in the background. But this happens so fast, we don't even notice it. And honestly, most people aren't aware of this even being a thing. Next up is MAC versus IP addresses. And we're going to cover these pretty quickly here. Media access control is essentially a sort of address that's assigned when a piece of hardware is made. For example, if you have, let's just say you have a laptop. That laptop has a MAC address that is created and assigned when that device is actually created. So you can have, for example, a Chromebook. Once that Chromebook is manufactured and made, it gets assigned a permanent MAC address that cannot change for that specific device. So MAC address, it's assigned to that device. IP address, on the other hand, can be assigned to a device, but it can change. MAC address for a device cannot change. Every device has a unique MAC address, but every device does not necessarily have a unique IP address. Because, for example, if we have 5 laptops that we're working on our computer on one router, anytime we visit a site, it's just going to look like it came from the same IP address, no matter if we're using multiple devices. The reason why that is because the IP address is assigned to essentially a network or to a specific like customer. So for example, if you use Comcast as your internet service provider is going to assign you out an IP address, and it's going to look like, because you're connected to a router, any devices from your home having the same exact IP address. And your IP address can change. So let's go over these rather quickly here. Type of address, MAC address is, again, it's a physical address built into a specific device, laptop, computer, tablet, whatever it is. IP address is a logical address that's assigned by a network or an internet service provider. Uniqueness, MAC address is unique to each device, doesn't change. IP address is usually not unique. They can be reused and often recycled. They're usually not permanent. So your IP address can change, especially if you use something like a VPN to sort of artificially change your IP address. MAC address is, again, it's assigned by the manufacturer at the time of manufacturing, and when a device gets shipped out, it should have a MAC address assigned to it. IP address is assigned by a network or it's manually configured. Primary use, MAC address is used for communicating within a local network. IP address is used to identify devices on a network or on the internet. Here is an example of a MAC versus IP address. So MAC, remember, that's our hardware address. This is what it would look like. And then IP is our network address. This is just an example of what that would look like. Next up, we have IPv4 and IPv6. So these are two different types of internet protocol technologies. So IPv4 is Internet Protocol version 4, and then we have IPv6, which is Internet Protocol version 6. IPv4 is the original version of Internet Protocol used to identify devices on a network. It uses a 32-bit address with 4 numbers separated by a period or a dot. So for example, 192.168.1.10, that's an IP address. This period here, that's not part of the IP address. That's just ending off the sentence. So don't look too much at that, but it's separated by 1, 2, 3 dots or 1, 2, 3 periods. And it has 4 numbers in that sequence. So because IPv4 has a limited number of addresses, we use private IP addresses to conserve space. IPv4 nowadays is still widely used across many home and business networks. IPv6, on the other hand, is much newer. IPv6 was created to solve the address shortage problem of IPv4. Because the thing is, because we have a limited amount of numbers here, there's only so many IPv4 addresses that are possible. IPv6 was made because we're eventually going to have a shortage of valid IPv4 addresses. IPv6 uses a 120-bit address written in hexadecimal, which allows for a very huge amount of unique addresses with IPv6. IPv6 is fairly efficient as well, and we're gradually using it alongside IPv4 in modern networks. So we're still using IPv4, but many different types of internet service providers are also starting to implement IPv6. One thing I wanted to mention with IPv4, we have what's known as private IP addresses, which are used for internal network communication. So for example, if you are working in an office and you have 20 different devices, each device is going to be assigned a private IP address for your specific network, but your entire organization is going to have a public IP address for that network that's used to connect to the internet. So private IP for IPv4, that's used more for internal communication, printers, laptops, computers to connect to the actual network, and then our public IPv4 is just for browsing the internet. Common protocols, you definitely need to know these. They're fairly simple. We have HTTP, HTTPS, FTP, and SMTP. You could read out each of these here, but just understand HTTP, it's used to load websites. HTTPS is encrypted HTTP. FTP, or file transfer protocol, that's used to transfer files between computers on a local, well, not necessarily on a local network, both on the internet and on a local network. So FTP can be used for both. Next up is SMTP, or simple mail transfer protocol. It's used for sending emails. HTTP works by sending data between a browser and a web server, and HTTP is not secure. HTTPS protects data using SSL, so it is encrypted. HTTPS is used for secure websites, for example, logins, payments, things like that. FTP is used for uploading and downloading files or transferring data or information through files. FTP is not encrypted by default, but it does have capability for encryption. Just like FTP, SMTP is not encrypted by default. It does have possibility and potential for encryption, just like how FTP does, but by default, it is not encrypted. And here's a quick checklist that you can pause the video to look at. This compares HTTP, HTTPS, FTP, and SMTP. So in this one, we covered some of the different network concepts that you need to understand. We finished off our look at high-level overview network concepts, and now we're going to be going into small networks.